Hello. Hello, this is the third installment of Oripy's art series, featuring Battleship. It is, well, I'm not gonna give you the name of the Sudoku puzzle yet, but yes, the pencil puzzle is known as Battleship, and it involves this sort of war ground where you place ships onto a grid. So yes, let's look at the rules of the puzzle. Yeah, you can see here. Alright, so the rules of basic Battleship are: place every ship from the fleet into the grid. Ships can be rotated or mirrored, so you see there's a selection here. In the final grid, you must place all of them in the grid. All ships must use exactly once. There cannot be ships in the grid that aren't present in the bank, which I assume is this little collection of ships here. You must use every ship once, and every ship must be used. Two ships cannot be orthogonal or diagonally adjacent, so something like this would not work. Numbers outside the grid indicate how many cells are occupied by ships. So here you see there's a 1 in this column, a 2 in this column, and a 2 in this column, which imply, well, it gives how many pieces are in that column. Some ship segments are given. So yeah, you can see here a side piece is here. Along with their orientation. So this one is the end of one boat that is sort of horizontal. Grey cells represent ship segments of unknown shape. Well, we don't have that in the puzzle, so we don't have that in this example puzzle here as well. But yes, it gives you some segments which you have to use to solve the puzzle. Cells marked with water, which are the waves here, cannot be used by ships. So in the end, yeah. Does it show here? I mean, I would expect it not to be, but yeah, you cannot place ships in the water, basically. And those are the rules of Battleship. So, I think we can just get into it. Yeah, let's just get into it. Alright, so, I'm gonna reload the page so we can start the timer fresh. And here, we can see that, well, because of this one, there cannot be any more ship pieces in that row, and because of this, it must connect to something here, and so must this. The marking is a bit interesting because this marking with a pointed edge as opposed to a rounded one implies that this is either a square piece or it is the end here. We don't actually know. Once I do this, then it becomes a square piece. Yeah, and marking this with water turns into a rounded piece as expected. Okay. Now this piece must be an extension. Well, it can't be a singular piece because a singular piece would be a circle, so it must extend. And in fact, because it's not round on any edge, it has to extend in both directions. So it is at least 3 long, and we know that. Right, and because this is the edge, we know it does not extend. Same for this actually, we know ships cannot touch horizontally, so there cannot be a second ship on this side. And in fact, yeah, even if this was, you know, there can't be a ship here at all because they cannot touch diagonally. And in fact, I think what that means is actually that no two pieces can be diagonal to each other. And the reason why is because suppose you have a piece here. If you had another piece that was diagonal to it, then you cannot connect them like this, right? Because all your pieces are straight. And this applies to classic Battleship. There are of course other Battleship puzzles where your pieces are not straight lines, but in this case it's all straight lines. So we know that those cannot occur because your piece cannot have a bend in them. But now because they're part of different ships, they cannot touch diagonally, and this would violate the rules. So what that means is basically pieces cannot have other pieces diagonal to it. So we can just do that immediately. Same for that. I think I'll just color that blue just because. Okay. It's interesting that we can actually do anything here at all. Maybe this 6 will help us. Oh, you can click on it. Right, you could do that with the 10th one also, I think. 2, 4, 6, 8. It's a 10 by 10 puzzle. Oh, I see. Yeah, this one we know cannot extend here, and the reason why is because if it did, it must have another end on the outside, which doesn't work. So actually this must extend like that. right? Which means it must extend on both sides like so, similar to this one over here. Right, we can actually color both of those as not having any pieces. Because, you know, this forms a bend. All right, the bend here is rounded because we know it's rounded. So we can do all of that, similar to what we did at the very top. Let's mark that as empty. Oh, and therefore this 4 over here, we can just mark all of this as parts of a ship, which gives us one of these 4 lengths. And we can mark all of those as not having any pieces, meaning this becomes a 3 length, which we've used. Now this one could still be a single ship. Oh, this 6. Well, there are 7 spaces here, and I think any of them could be empty. No, the ones on the outside can't be empty, because if this was empty, for example, then this forms a 5 length ship, which doesn't work. So the outsides cannot be empty. Oh, sorry, the outsides cannot be empty, so they must be ship. And then we can mark the parts, the spaces adjacent to them. And well, I don't know which one is the final empty cell. Isn't it very similar here? Because we have one piece here, right? We need 3 more. I mean, those 3 could just form another 3 length. Unlike the 6, which, you know, forms a 6 length if there is nothing separating them. Alright, maybe this 4. Oh, I don't see much there. Oh, sorry, this 1 means those are both just empty. This 2 is also complete, so all of those are empty, which gives us the 4. All those must be part of the ship, which gives us a 2 length. This could also be a 4 length because we haven't used up all of them yet. Right, now what? Oh, this 4 now, we can place all of those down. We don't know what they are though, they could all be 2 length ships, I think. Oh, except that this must now be shaded because pieces cannot be diagonal to each other. So that uses up another one of those. Actually, don't we? Oh no, this is not. I saw this as a 2 length somehow. Alright, I think I see something. This 3 over here means that 3 of these 4 cells are part of a ship, but whatever this is, right, cannot be connected to whatever's up there. Because we know of this 6, every piece from the 6 must be part of a horizontal ship. And therefore what I'm saying is that you cannot have either of these be empty, because that implies that those 2 will be connected. So they both are part of a ship, which gives us all of that. This could be empty though, and it could also be filled. But it can't, because if it was filled, then we know this is empty. The 6 must be completed like that, and you have them connected diagonally. So this cannot be ship, and that must be ship. We've used out another 2, so let's do that. And this one connects to one of them. Obviously not both, but one of them, which gives us our other it gives us our other 4 length, which means this can't be ship. I mean, we already knew by the 3, I guess, that it wasn't part of a ship. But oh, we also know that this is not a 4 length, so it has to do that. So that gives us 2 more 3 length ships, which works. That uses all our 3 length ships. There is a 2 length and a 4 length here. Those are the 2 length and the 4 lengths, which means all 3 of these we haven't done are all 1 length, which uses up all of them. And because that's all our ships, every single other cell is empty. Right, and this 2 means that this is the one that is ship. There you go. Took me a while to figure out that final part, but we got it. Okay. So that's regular battleship. Can I mark you? Oh, I can. Whoa. There you go. The entire grid is now ocean floor. So that's cool, but what about regular Sudoku? Well, not regular. What about variant Sudoku? Kaiserliche Marine? 5x5 for this one. Right, so let's look at the rules for this variant. Normal 5 by 5 Sudoku rules apply, so place the digits 1 to 9 in every row, every column, yeah, place the digits 1 to 5 in every row and every column. Battleships, place the given fleet of ships. We have a 2 length, 2 3 lengths, and a 4 length here. So that no 2 ships are touching, not even diagonally, so regular battleship rules. A clue outside the grid indicates the number of cells in the corresponding row. So a clue outside the grid here, which you can mark for some reason. Same for here actually. I think the 9x9 you can also mark, and you can see the grid is kinda large. It's kind of zoomed out a bit. I think it's just because we need to display the entire fleet here. But yes, this number shows you how many cells are battleship. A clue outside the grid, yeah, okay. German fleet, right, that's why the name is in German. Oh, also, fun fact, Kaiserliche Marine in German is Imperial Navy. So, German Whisper lines, adjacent digits along the line must have a difference of at least 3. So suppose your battleship looked like this. Then this forms a German Whisper line, where digits must differ by at least 3. So you could have something like this, you know. Right, so digits separated by a and crop key dots, right? Digits separated by a black dot have a 1 to 2 ratio, so one digit is double the other. If this was a 4, then this digit would have to be a 2, for example. And those are the rules. So let us start with this smaller variant. Okay, so what do we do first? Well, it's pretty interesting because that all of these are German ships, right? This is a German Whisper line that is 4 long, which means something, because if it lands on a certain row or certain column, because we allow rotations, what digit is not on this ship? It will always be a 3. And in fact, 3 can never be on a Whisper line for this grid, because if you look at the digit 3, what digit is 3 away from that? You either have 0 or 6 at the very least, and at the very most, I guess. But 1, 2, 4, and 5 can never be beside 3. So that means 3 is not on a German Whisper line, and for a 9x9 it's going to be different, but the idea still stays the same. So wherever you put this, it is simply a fact that 3 cannot be there. And in fact, there is a certain order in which you have to have a line though. So, oh my goodness. So if we looked at a line, for example, let's say that's a line. Do I draw a line like this? What was it? I mean, black lines are pretty hard to see. Let's use green. Yeah, let's just use green because here our battleships are green as well. Let's use green. Suppose this is a German Whisper line of some sort. Because 3 cannot be here, we can say that 3 is outside. But we can also say there's a certain sequence of digits you must have on a German Whisper line. And those digits must be in, well, either in one direction or the other. Notice the 2 and the 4 only have one option each. The 2 can only be next to 3. The 2 can only be next to 5. The 4 can only be next to 1. So the 2 and 4s cannot be in the middle because there is no way you can put 2 different digits be around the 2 or the 4. So 2s and 4s have to be outside. 1s and 5s have to be on the inside. And also, the 1s have to be next to the higher digits 4 and 5, while the 5 has to be next to the lower digits 1 and 2. So you always have this set of digits in some order, either forwards or backwards, in this case up or down. But yes, it is pretty interesting though. Where in the world would we place this line? Well, actually, can cells with crop key dots contain battleships? I think they can. Yeah. Okay, so you know what? It actually looks pretty hard to fit all of this on screen without touching each other. Like, one way I can see you do it is, you know, something like this. But actually that feels really cramped. because of the fact that they cannot touch each other. And in fact, the 4 length cannot be on this column, right? Because if it was, then you basically have... Okay, I'm just going to use shading. If it was like this, then you basically have all of those be non-ship. And then you could fit 2 pieces on either side, but you can't fit all 3. So the center row and the center column cannot have that 4 length. The 4 length must be on the edge. Can the 4 length be in here? Say this is a 4 length. Then the 2 rows beside it cannot. Yeah, and how do you fit 3 pieces in here? You just can't. So that actually means that the 4 length must be pushed against the edge. I'm suspecting it's one of these edges, but I can't really tell. Yeah, and okay, how would you fill up both of these 4s here? I'm pretty sure this cell must be filled. Yes, because if it wasn't, then you'd have all of those be filled, and that doesn't work. So this cell is part of a ship, and that cell is therefore not, because we know diagonal cells cannot contain both ships. Right, okay, so now I do know that this one has to be a 4 length in some direction. That is because if it wasn't a 4 length, then how would you have 4 cells be part of a ship if it wasn't a 4 length? So look at this 4 over here. If this wasn't a 4 length, then it is at least a 2 length. And I guess because this grid is... Well, these 2 clues are diagonally symmetrical, we can look at either one of them without much loss of generality. Sorry if I'm yapping here, but this one over here has to reach out in some direction, and let's assume it reaches out in this direction. Because of that, we know that it at the very maximum reaches out here, right? Oh, that is possible. Is it? Wait, yes it is. I think it is barely possible. Okay, so... Yeah, okay, I've just proven by myself that it is possible for this to not be part of a 4. Don't mind what I'm saying. Wow, okay. Whichever the 4 is on, well, whichever side the 4 is on, there's also a 4 in this column. I don't know if I want to look at that 4 over there. The 4s have to be separated somehow, right? I mean... Okay, well, in total we can say here that there are, what, 8 ship pieces here in these 2 columns. I think that might be one way to think about it. What are those then? Well, how many pieces do those take up? 6 from the 3s, another 6. Okay, so this takes up 12 cells. 12 cells. 12 cells. So that 8 here, there must be 4 more on the outside. Oh, I could probably color a lot of these as not part of a ship, right? Yeah, in fact, none of these are ship. Wait, yeah, none of these are ship. Because if this is a ship... Oh, wait, no, sorry. None of those are ship. Those could be ship. I don't know what I'm thinking. I'm thinking that if this is ship, right, I can say that the diagonals are... the diagonals are not ship. So I can say that none of those are ship. Yes, because if a ship was here, the diagonals are not ship. And therefore, you'd only have 3 possible ship cells in here, which does not work. So none of those are ship. These can be ship because they only touch 1 diagonal cell in the column next to it. So there you go. Could I say the same for here? Yes. Yes, there you go. Because there are 4 cells here, none of these cells can be ship, which gives us all the ships in here. So none of those are ships now. Sweet. That is one of the 3s. I don't know how to change the numbers here, because I can't really do anything to that number. It's fine. See, this is why I chose the puzzle with the full fleet here, so I could just color them off whenever I wanted to. In fact, what we're coloring, I don't have a black, but I have a grey. No, I think red or green might be useful to say we've used it. But that's not important right now, we're just doing more coloring. Okay, we've used one of the 3s. We still have a 2 length to go. If that is shaded... this takes up the other 3. If this is shaded... Oh no, it could be a 4. If this is shaded, this could also be shaded to give you 4 length. Otherwise, if this is unshaded, then those 3 will be shaded to give you a 3. Yes, this must be shaded. If this is not part of a ship, then all of those are ships which give you two lengths, which don't work, so that is shaded. I mean, I guess it's very similar to that. I think I can place a digit here, and I can put a 3 there because all those are part of German Whisper, which means 3 is not on those cells, so that's 3. I mean, should I? I don't think there's a real reason as to why I should. Okay. What do we have? We know that there are 8 ships here, so those digits have 4 more ship pieces in them. Ship pieces. And because of this 4, we know that there are 2 ship pieces here. So there are 2 more ship pieces over here. Is that useful in some way? If I marked you with a 2 and said that, well, this red area has 2 ships in it. 2 ship pieces in it. It could be part of a 2 length. It could be part of a 2 length, or it could be part of a 3 length like that. I mean, it can't be part of a 3 length. Oh. Actually, yeah, this thing over here, I believe this forms a... It forms a 4 length and a 3 length, right? Yes. It forms a 4 length and a 3 length. And the reason why is... I don't know the reason why. Wait, I need to figure out how to say this in words. The reason why is there are a total of 7 shaded cells in these 2 regions. There are 4 here, 4 here, 1 is double counted. So in total there are 7 shaded cells, which have to be 4 and 3, right? Why is it not something else? Because if you had a 2 length, then the remaining 5 cells must form ships in some way. You can't have a 5 length, and you can't have a 1 length, so... Yeah, you can't have a second 2 length either. Yes, which means that there is no way to make the last 5 cells in ships. Which means this has to be a 3 and a 4. So whichever 2 cells here form its own ship, it forms its own ship. What does that mean? I don't know, but can we say that that's a ship, or can we say it's not a ship? It's possible for this to be a ship if your remaining configuration looks like that. And then vice versa. This could be non-ship if your remaining ships look like that. Why is that? Oh, that's why. We already know that's 3. See, I should have marked it. That's 3. And I think it's a bit hard to see, so I might use a different color for water. Do we have a brighter color? I think this is better. It's slightly better. It's less dark. Right? If I compare a bit, yeah, it's less dark. I think that works. So yes, this is 3, which means that this can't be an empty cell, because if it was, all of those are shaded, forcing this to be a 3. So that is shaded, which gives us basically everything, because once it's shaded, we know that this can't be part of a ship anymore, so all of those are shaded, which means that this can't be part of the 4, which means this must be part of the 4, so that must extend. And there you go. Where are my C pieces? There you are. That must not be ship, which means that your 2 length must be here. That must be shaded. And it can go in either way, but I don't think we know how. Right, so now we know that that's 3. We know that that's 3. So in this row, where does 3 go? 3 can't go there, 3 must go there, which means that in this row, 3 must go here. The 3 is not part of your ship, which means the ship must be here. I marked a 2 there because it's 2 length, but doesn't actually have the digit 2 on it. This one we already discussed, a 4 length has to be in a certain order. The 1s and 5s are inside, the 2s and 4s are outside. This is a crop key dot. Well, that means 5 can't be here. But 5 could be there. Or there. So I guess we don't know. Well, we know 2 cannot... 2 and 4 can't be in here. So that's 1 of 5. Same here, 1 and 5 have to be here. 1 and 5 have to be there. What else do we have? I guess 5 can't be on the crop key dot. Is that useful somehow? Besides just marking 1, 2, 4 here. Well, I guess then it must have a 2 in it. Which could mean something. Does it mean anything? It's either 1, 2 or 2, 4, which is why I say it has a 2 in it. No real idea. Although I guess, you know what? Shall we talk about parity? Or polarity, sorry. We might have to do that when we do the actual 9x9 puzzle, but I think at this point we don't really need to yet. Nah, I will talk about parity. Okay, let's start by marking down all the ships first. So those are all ships. I'm gonna get rid of the color because coloring is useful. Let's start by coloring all the 3s as a certain color. Now, yeah, let's start by coloring them pink. Whoa. Okay, so how a German whisper line works is that you can prove that every alternating digit is of the same polarity, or that along a line you alternate in polarity. And the reason why is because if you think of the number line 1, 2, 3, 4, and 5, which, can I do this in a cool way? 1, 2, okay, I can't do it in a cool way. I could do it here, I could go upwards like that. I think that's really dumb though. But if you think about a number line, because 3 can't be on a line, you have 2 groups. You either have the 3 here, you have 2 groups. You either have the digits below 3 or the digits above 3. These form 2 different polarities, right? The low one and the high one. If you select a digit from the low parity, there is the only way to get a digit 3 or more away from it is if you select from a high parity, and vice versa. And therefore, for any digit here, if it's of a certain polarity, the digits adjacent to it must be of the opposite polarity. And therefore, we can sort of start coloring and say, what polarity is that? Well, we don't know, but let's say it's of a blue polarity. We know that every row and every column has digits 1 to 5, which have 2 lows and 2 highs, plus a 3. Therefore, we can say here that this must be where the other blue is, because those can both be blue. You then have 3 blues in the row, which doesn't work. So that is also blue. Then those are of the opposite polarity, which we'll say is orange, which we can apply on this line as well. Orange here means now those can both be orange, so orange has to be here. Those are therefore both blue. Those are therefore both orange to complete the row. Those are therefore both blue to complete the row. That digit must be orange because of the line. That digit must be blue to complete the column. That digit we don't know. This is one polarity, but it could be low or high. Yeah, so those digits have questionable polarity, which we don't know. But maybe that could help us. Right? Because those are of the same polarity and contain 1 or 5, they must be the same digit. Yeah. They must be the same digit. Does that help? Yes, because where does this digit go in this row? It can't be here, and it can't be of an opposite polarity, so this digit actually goes in there, which now must be 1 or 5, and therefore that forms a 1-5 pair. Those remaining digits are 2 and 4. We can do the same here as well, I think, by saying... Which one shall we use? Those 2 digits? Does that help? I don't know. I don't think so. Okay. Whatever those digits are, actually that digit... That digit and that digit are both low parity and 1 or 5, so they are the same digit. Does that help? Well, yes, because this digit is of low polarity and this is the other low polarity digit. This digit is also the other low polarity digit. They are the same, so that's 2 or 4. Which means that that digit and that digit is the same, so that's a 1 or 5, which you could also tell from the 2-4 pair here, leaving only 1 and 5 here. Now, we know those 3 digits are the same, but we don't know where it goes in those 4 cells. What else do we have? We know those digits are the same, I guess. Does that do anything? Why does it look like it doesn't do anything? Oh, no, sorry. I was like, oh. No, I did not figure it out. Wow. Really? What is there here? I mean, if those digits have the same polarity, they're just 1 and 2, right? Does that do anything? If it's of different polarities, we know it's 2 and 4. But if they're the same polarity, we know it's 1 and 2. Which gives us a bunch of stuff to work with. I think it's just something I'm not seeing. How have I spent 20 minutes on this already? I mean, yeah, there's gonna be edits here because I was a bit interrupted while I was doing... Is that music outside I can hear? I'm like closing my door a bit more so that we can actually think. I don't know, because those digits could be the same, but those digits could be the same, right? Those 3 digits are the same, which form a sort of X-wing of those digits here. Those digits are the same. Oh, which must be that digit. Right, yeah, obviously, because this digit can't be here, it must be there. So, there it is. And now, this forms sort of an X-wing here, where it's either those 2 digits or those 2 digits. Now, we still don't know. Same for the 5s. 5s are either those 2 digits or those 2 digits. 5s? 1s or 5s. Now, I think we can do the exact same with that set over there, which must be in one of those cells. This set over here might be slightly different, but I don't think it's much different either. Yeah. Oh, this can't be 2 or 4. Right, because 2 and 4 as a pair do not differ by... 2 and 4 as a pair do not differ by, you know, 3 or more. So this has to be from the other one. This has to be 1 or 5. Right, which gives us a 2-4 here, which gives us... what? Well, the 1-5s are now officially in there. So that's blue, which gives us a bunch of stuff, because now that's orange, that's blue, that's orange, and now that both of these are the same polarity, we know there are 1 and 2, which means that oranges are only 1s and 2s, which gives us a bunch of digits. So that's 2, that's 1. This must not be 2 because it's orange. So that's 2, that's 1. And now the blues are 4s and 5s. So those are 4s. That's 4. That's 4. That's 4. And the last digits we can place are the 5s. There you go. Wow. Yeah, I was told that this example would be pretty tricky. But I did not expect it to be tricky like that, you know. Can I get rid of the lines as well? Okay, you don't need to tell me I've solved the puzzle every time. I was just simply trying to color in your ships, which look like this. There you go. This is your battleship. Okay, so 37 minutes into recording, let's actually get this done. We are now looking at the full 9x9, and hopefully this is a big enough screen for you to see. I'm pretty sure going to the regular screen share is not doing us any favors. Yeah, in fact it's zoomed in here, so let's just use this screen. Right, so I assume that the rules are we know the rules. Oh my god, the dots are huge. Whoa. Yeah, the dots are huge. Wow, okay. It's fine. We have a 5 length here to work with. So yeah, okay. The rules are place ships in here based on these numbers. Ships may not touch diagonally or orthogonally. All ships must be used, and ships form German whisper lines. Right, for a 9x9, the German whisper line has one digit that cannot be on it, and that will be a 5. So we know that that immediately is not ship. But there is no restriction saying that given digits can't be ship, so that could be ship if I wanted it to be. Yes. Okay. Five length is actually really interesting to think about, but obviously a 5 length ship is actually not going to be as restricted as a 4 length ship in the 5x5, because that one can actually say has to be of a certain order, but the 5 length is just too short for us to do anything with it. Well, I guess we might be able to do things with the 6 though. Although not really. Let's see. There must be some you know, synergy between this rule set and the Kropki dots. I'm not seeing it though. I guess Kropki dots kind of a 5, 7 or 9 on them, because Kropki dots in a 9x9 don't have pairs to go with 5, 7 and 9. So I guess as a little recap, what digits can we place in Kropki dots? The digits we can place are 1, 2, 2, 4, 4, 8 and 3, 6. Only those digits can go next to Kropki dots. So no 5, 7s or 9s. Well, this forms a length of 5. Wow. Yeah, actually, let's think about it. Because these digits are consecutive due to crop. Oh, I never actually explained what Kropki dots in a sorry, a white Kropki dot means digits have to be consecutive. I never actually said that. We know what black Kropki dots do. They are ratio 1 to 2. The white Kropki dots are consecutive. Yes, I thought regular rules would apply, but there is one more thing in in here that was in the previous puzzle. So what that actually means is that digits here and here cannot be part of a ship, because whichever direction they grow in have to be consecutive to it and are not going to differ by at least 5. So those are not part of the ship. Actually, this forms a length of 5. But this could be ship if it grew this way. So, you know, your ship could look like that, and then this could actually form a thing here. It doesn't have to be consecutive to this digit or whatever. We can do the same for every one of those, I think. Yeah, and in fact, this forms a length of 6. I hope you can see what I'm drawing here. But this forms a run of 6 digits, which means that those digits could actually be both part of a ship. because they differ by 6, which is fine. Huh, that's funny. So this could still be shipped, even though this probably can't be shipped with that. Okay. Well, those digits actually do split the 5s up. We cannot have a 5 length shipped in any of these rows. Oh, I just realized, yes, this 6 length cannot have 5s at the end, right? Because 5, yeah, if you think about it, those digits have a difference of 5, right? Have a difference of 6. And because they have a difference of 6, they form this mini whisper line here, which cannot have 5 on it. So 5 can't be here. I think 5 can't be there either, because those two digits differ by 5, and if 5 wasn't there, that doesn't work. Same for this one over here. So now none of those digits are 5. I guess that means 5 is in one of those digits cells. That can't be 5 because it's next to a dot, but can 5 be there? Yeah, 5 can absolutely be there. Why not? How does that help? And can you guys see? I assume you can. I hope you can. Oh, we do have... Oh, okay. Because of those two are definitely not part of a ship, we do only have... we only have 7 remaining cells, 6 of which must be ship. Yes, and this one can't be non-ship now, because then you have 6 in a row, which is none of these ships. All ships are at most 5 in length, so that must be ship, which we now know can't go into here, because those only differ by 1. Therefore, this ship must at the very least extend out here, which is fine because they differ by 6. So there you go. We have something going on. Therefore, none of those digits can be ship. Wrong color. None of those digits can be ship. I should probably color ships in a different color than grey because I have to toggle every time. Let's color them pink. Yeah. A pink ship. Pink ship. Right. Oh, and now this 5, well, this 5, we just know those are all ships. Which actually cannot have any of those be shaded ships as well. So that gives us a 2 and a 3 to be used up. Let's use any color to just mark them off. We use like a interesting shade of pink here. I don't remember what specific color this was, but okay, this is a good start. And in fact, the one here is actually just completed like that. So there you go. This 7 was in fact not part of a ship. Right, so now what? This 5 has 7 empty cells. How's that gonna work? I don't know how that's gonna work. If this was ship, well, all ships will be at least too long, so we have that. Oh, actually, because this one is also too long, we can mark that one off as used up. Yeah, we have a 2, a 2, and a 3 here. I guess at some point we have to have a 5 length, which might be what we're going to be concerned about. I am suspecting that the 6 has a 5 length directly in the middle, but I can't be so sure about that. And like, as opposed to this one, trying to work out how many ships you can fit in a given grid is way tougher because it's so big. It's like, no, I don't think that's feasible. Oh, well, I guess I can say none of those none of those are ship, because there are 5 out of 6 cells here that are ship, and any one of these being ship would remove 2 cells as not part of the ship because of the diagonal rule. So none of those cells are a ship, which means that can't be ship because it must grow out to here at the very least, and those 2 digits are consecutive and do not differ by 5. So it cannot form a German whisper line and therefore are not a valid ship, so that's not ship. Right, so where does your empty cell go? It can't be here, because if your empty cell was here, then this one must be its own single ship, which doesn't work. So this we know is ship. I mean, can we say that about this as well? No, because this could be empty if your ship looked like this. I think that's fine. Yeah. So this is the only one I could say that for. We've used up like so many of the clues already. This is the only one we haven't used yet. I guess it might just be trying to fit stuff in here. Alright, I'm back. I got a little stuff to do just now, but we're back. And I kept the timer on even though I wasn't looking at it, but it's fine. I'm not really concerned with the time at this point. I think this will be edited, so yeah, all the unnecessary pauses like from everywhere in the past video will be removed. Anyway, let's continue with, you know, just not finding it for some reason. I feel like at some point I just have to do like regular battleship, because how am I fitting every single one of these ships in here, right? It's like, let's think about where the 5 length. Okay, what do we have so far? We have those. We haven't fit in all the small ships yet. Maybe that's why. Maybe we are meant to think about how. Well, okay. Every column can fit. It either fits one of those, or it fits the 2 small ones, or it fits the 2 and the 3. Every row does that, and we have 5 available rows if we sort of think about it, because whenever you put a ship here, right, it takes up a lot of the row next to it. So theoretically, let's just look at these rows and see what we can do with them, right? So suppose we have 2 sets over here, each of these. Let's say we use them in 2 different rows, and I will move those here. So let's say that goes there. We still need a 3, 4, 4, and 5. And that's just not possible because you're gonna have 3 possible rows. Even if you had the 4, 4, and 5 in here, you would be missing a 3. So I guess this is not the optimal packing then. Which means that somewhere in here, you have to. You have to pack it differently in here somehow. But I am sort of assuming, because you know, 4s and 5 lengths can only fit horizontally in here. I mean, I guess I guess ignoring this, you could put a 4 here though. That is a thing. I mean, I just want to try figuring out how I would attempt to fit everything in. So I'll remove this color. Let's attempt to fill this place up first. Let's put a 4 here, a 4 here, and a 5 here. Let's try. Which gives us all of those. We'll mark all those off. We still need 3, 3, 3, 3, 2. No, 3 3s only. 3, 2, 3, 2. Okay, that definitely doesn't work. So it's a different packing. So maybe something like 2 here, 2 here, 3 here. This is a bit tough. I mean, we could have a 2 there. Yeah, I could sneakily fit a 2 in there. Oh, and that probably gives us the entire thing then. No, wait. This is still a little bit of an issue. We could put another 2 there. Can we put 3s? No, wait, what? Maybe 3 here? Wow, wait, this is a very interesting problem, because I'm not seeing it. Either I'm somehow not making it work. Yeah, I don't see how I can fit this in here. I mean, Okay, maybe I just packed very inefficiently. Like, I want to put a 5 here to make it so that I have as much space over here as possible. I use up most of the space here, which means putting a 5 in there. Oh, wait, there's a crop key here. You can't put a 5 in here. A 5 here would definitely cross the crop key, which doesn't work on a German Whisper line. You can't put a 5 in here. And in fact, you can't even put a 4 in here because a 4 would do the exact same. Oh, whoa, so you need at most a 3. Is that doable? And my guess is that you can somehow find a way to fit every other piece in here, plus your extra 3 or 2 in here, and this 5 clue is going to tell us where the 3 goes. Okay, that is by meta logic, which I am not going to use, but I am going to try to prove that without a 3 you can fit every other piece in this set alone. And to start, I'm definitely going to use up that cell to make it as efficient as possible. And alright, how am I going to pack this? Again, I want to use space in the most efficient way possible, right? See, there's an option now. Do I put 5 here and 4 here, or do I put 5 here and 4 here? I mean, I guess either way there's going to be ships in all those cells. See, the point is if I put a 5 here, right, none of those cells can be shipped anymore. And if I put 5 in here, we can still fit a 2 in there. So I think this is actually more efficient. And if we had a 3 here, then what we've used is, we've used all of this. I'm gonna mark that with orange. Is that possible? And then, yeah, because the 3 goes in here, we said we've used it. Is it really possible to fit that in here? What? Oh, you could put a 4 length in here. That is very efficient, yes. And then your 3, 3, and 2, I guess you could just try. Yeah, I don't know, it still doesn't feel possible, honestly. Yeah, it doesn't. Wait, how? Oh, because you could put a 3 and a 2 in here. That's how you do it. Right, this is not just a 3. You could put a 3 in here plus a 2 in here. There. Which probably must be the case then. Because you cannot fit anything else in here. You must have one missing. And my guess is that now we can only fit a 3 and a 2 in here. We've therefore used another 2. Which means we need to fit 2 3s in here. Which, yeah, it's possible. It's actually quite a lot of leeway. You could even have them be horizontal like this. Oh, yeah, because of this 4. That doesn't happen. Alright, so what does that mean? For this over here, right, I think we have sort of proven that there must be 2 ships here. There cannot be a 2 and a 5. Sorry, there can't be a 4 and a 5. 4 or a 5 in here. So this ship must be... This area must be occupied by a 2 and a 3. And a 2 and a 3 must always have ship segments here. You either have a ship segment here, but we don't know. I want to say that it's forced to have a ship here as well, but I can't prove that. And in fact, that is actually a little worse. Well, no it's not. Yeah, no it's not, because you could always have something like this go on. But we have a 2 and a 3 here, so I guess it's safe to mark those as all used up. Can I prove that those are both ship segments? I mean, I think it's a little bit harder to do that. Yeah, it has to be a little bit harder to do that. Okay, I can't believe this puzzle has evolved into a packing problem. We love packing problems. You know, have you ever seen like that one meme where it's like the most optimal way to fit 17 squares into a single square? It involves some really cursed configuration of squares that are like very haphazardly put in. It's crazy, honestly. And I think it's funny in its own right. Okay. What do I want to prove with this? Do I have to put a 5 in one of these columns? Or what if I put a 5 in that column? I mean, I can always replace one of these columns with a 2 and a 3. That's even more efficient than a 5, I think, because... No, it's actually less efficient because it has a space in between, which is basically fitting 5 ships into 6 cells as opposed to this 5 length, which is just 5 ships in 5 cells. So it's slightly more inefficient. Yeah, and in fact, if you put a 2 and a 3 here, you can't put anything in here, which means that this section over here now has a total of 4... has a total of 5 cells instead of 6, which is possible if you did something like this. So I guess if you're looking for efficiency, this is a much better way to pack it. Although I guess we're not looking for efficiency here more than the correct answer. I feel like with this small number of dots though, it has to be efficiency. Like there's no other way to prove anything other than this is most efficient and only the most efficient will work. But again, that's meta logic. If I did this, right, what do I need? 4, 2, 3. I need a 4, a 3, and a 3. Yeah, that's not that tough. Actually, no, it might be a bit tougher than I thought. Wait a minute. Wait a minute. Wait a minute. Because of this, you can only fit two cells in here. This can't be a 3 length horizontally at all. Oh, that might be an issue. Yeah, in fact, therefore, maybe this is more efficient because this allows you to fit 3 in here. Whereas when I did this, I could not fit a 3 in here because of the 5. Huh. Alright, so maybe let's prove that this is wrong first. If this happened, then we know that all those cells have to be not part of a ship. Sorry, not part of a ship. We would also have used up those, which I'll mark with orange just so I don't confuse myself. Now we get a 5, which can be placed here. That is very good to have, and even if we did, which is most efficient, there you go. Now we can use most efficient as part of our example. And I guess we have to because of the 6, right? These must all be filled. So it's not even about efficiency, it's just that it has to be. this now can't be part of the ship, because if it was, it would have to extend out twice because it has to be at least 3 long. And now we have to fill this space in with a 3, 3, and a 4. How? Well, there must be 2 here, so my initial guess would have to be, because you can't form 3 in a row, and you can't form 2 in a row because you can't use 2 lengths, you have to have them both on the outside, which must stretch down at least 3. Right? But now the issue is, where do you fit the last ship? Because whichever reaches... Yeah, because you can't fit a 3 length here, because where's your 4 length going to be? And if either of them were 4 length, then how would you fit a final ship? Yeah, so I think this is not possible. I hope that was a rigorous enough proof. But I guess I can then say that you can't have this quote-unquote most efficient method to pack. Which I think therefore implies you have to do it 2-3. That means that's the next most efficient, which doesn't have to happen. But yeah, suppose I did it 2-3. Those are now empty. Sorry, empty. We can now fit a 3 length here, which is good. I think we will. And if I say I put a 5 in here, sorry, could I then fit whatever I need to fit? We would have used up a 2, 3, a 5, and another 3 at the top, which means we only need to fit 2 4s, which is possible. Yes, there you go. So yeah, I think this is actually just the most efficient way to pack it. It's the only way. Huh. Wait, that's actually very restricting, but it's so restricted that I really want to check if it's in fact the only solution. I think it is. And I guess this might be evolving into bifurcation, but I want to kind of roll with it and see what it does. So let's say that's forced, right? This is 5 length, which means those cells are all taken up. That cell is not shipped. Those 2 cells must be shipped because it must be 3 long, which always leaches into those 2 cells. The remaining 4 must be in those cells. It's the only way you can fit 4 cells into there. And this is what we have so far. Yeah, I just think this is all there is to it. Which is insane. Wait, no, that doesn't work. Hold on. Where does 5 go in column 5 now? Wait, where does 5 go in column 5? It can't go anywhere. It can't go on a ship. It can't go on a pink cell. It can't go next to a dot. So where does 5 go? Oh no, okay. Maybe there's another way to pack it. Oh, I think that might be. Yes, yeah, there is another way. Because what we did before is we made... okay, I can't do that, but... Whoa, what are you doing? What we did before is we made it look a bit like this, right? Where I say 2, 3 goes here and 5 goes here. But who's to say that this has to be a 5 in a row? And in fact, yeah, I can therefore prove that this can't be 5 in a row, because if it was, it would take up those 4 cells, and that we know where to put 5 in this, there'll be nowhere to put 5 in this column. So 5 can't go here. I think 5 must therefore go there, which means all those cells are ship. And so we can then run with our initial logic and then say that, oh, well, that's even better because now I can prove that the 3 cells must go there. And in fact, that must also be part of the ship, which gives us our 5. Yes, I think this is it. Hopefully. Which should give us every single ship. Save for the ones that are not yet filled in, but one of those cells are ship, one of those cells are ship. We don't know which. But now I can say that in this column, 5 goes in one of those cells. Whichever cell is not part of the ship. You can probably do the same for a bunch of other stuff as well. 5 in this box can't be in those cells, so 5 goes in one of those cells. I mean, 5 could be here or there, so that's fine. 5 could be there if this was 6 next to like a 4 or something. Okay, but I think this is a really good start, especially considering I'm 30 minutes in. This is a kind of good start. Right, where does 5 go in this column? There you go. 5 can't go in any of those cells. 5 can't go next to a black dot. This 5 means 5 can't go there, so 5 has to be there. That's a kind of a nice start already. Where does 5 go in here? 5 can't be next to a black dot, so 5 is in one of those cells. What if 5 was there? No, I think 5 there does nothing much different. Cool. So where does 5 go in this box? 5 can't be there, and 5 can't be next to a black dot, so 5 is in one of those cells, which means that's not 5, so 5 goes here, which now cannot be ship, so that's ship. Cool. Okay. I guess 5 is not in one of those cells, because 5 can't be here or here, because of this 5. What else can we do? I don't know. But I think this is nice. I guess because those are 5 digits that are consecutive, right? They must have a 5 on it. Because if you look at the number line from 1 to 9, and you take any section of 5 consecutive digits, they always contain a 5, which we know now can't be there. So 5 is in one of those cells. That does not help. I really want to resolve this because I want to start drawing the lines like I did here, so that I guess can start coloring by polarity. That has got to be like the solution, right? I think. I don't know actually. I don't know, but I guess yeah. Okay, sorry. 5 is in one of those cells, which means 5 is not in there. So 5 is in one of those cells, which means in this box, 5 is in one of those cells, which sort of forms an X-wing here, which is kind of bad, but I guess it works. And then this forms its own, like, weird thing, but it does loop, and it is actually unresolvable. I mean, if 5 was there, you need 4. Yeah, wherever 5 is, needs 4 and 6 on the outside. So I guess this must be 4 or 6 then. Because yeah, if this was 5, then those have to be 4 and 6. If this is 5, then those have to be 4 and 6. So that's something. And therefore that digit is either... Well, if it's 6, it must be next to 3. If it's 4, it could be next to 2 or 8. I mean, it is on a ship, which could tell us something. I don't know what it would tell us though. Uh, 5, 4, 3, 2. Oh, right. If it was a 4 here, then wherever you start from the 5, you must go 5, 4, 3, 2. So this digit can't be 2 then. Yeah, okay. So I guess we can eliminate 2 from that cell. If it was 6, then you would need 5, 6, 7, 8, which works because that could be a 3. So that's fine, but this being 3, 8 maybe could say something here. If this is a 3, 8, it could only be next to 8 or 9, but if it's 8, it could be next to 1 or 2. That doesn't help. And we also don't know its parity. So we sort of don't exactly get it either. And also because I haven't actually proved this entire grid yet, there is a slight chance this could entirely be wrong, unless I intuitively got it right and said that this is as best as you can pack it. I mean, I guess that is in the center of a ship, which could tell us something, because 4s and 6s can't be on the centers of the ships as well, because 4s and 6s only have one... 4s and 6s only have one neighbor, which have to be, sorry. They have to be 9 and 1 respectively, right? Which means that... Well, I guess that actually can't be 4 or 6. It could be 1, 2, 8 or 3 though, which doesn't help. Could be 1, 2, 3 or 8. And because the grid is so small, I don't think that's going to help at all. Eight needs to be next to 4, 3 needs to be next to 6, 1 needs to be next to 2, but 2 could be next to 1 or 4. Oh, I just realized, yeah, well, sorry, does 5 have to be there? 5, yeah, that... Why can't those digits have 5 in them? This 5 means that digit can't have 5, but why can't this have a 5 in it? Did I explain why? I don't know why that digit can't have 5 in it, but I guess because this is a 6 length, it must have a 5 on it. So those digits can't be 5. Meaning 5 is in one of those digits, therefore that digit can't be 5. Alright, we're getting somewhere. So 5 goes there, means 5 goes there. Which hopefully does something, but this probably forms a secondary X-wing. Yeah. 5, 6, 7, 8, 9, 4, 9. 4, 9 works on a Jamuspa. 5, 8, 5, 4, 3. 3, 4, 5, 6, 7, 8. Oh, they differ by 5 exactly. Did I say they differ by 6? I don't know why I said that. I guess because it contains 6 cells, but that just means it differs by 5. I don't know why I said differed by 6. But yeah, why can't that be 5? Why did I say that that could not be 5? I don't know, but what I can say is this one, yeah, okay, so one of those are 5s, which means that digit always has to be 4 or 6. Right, which forms a pair. And in fact, because this digit is now either 3 or 8, we can do basically what we did over here. Nice. So those digits actually, oh sorry, those 4 digits are a triple, which are, well, I guess they're 1, 2, 7, 9? Quadruple, sorry. 9. Actually, I think we could remove some stuff from that, right? 9, 8, 7, 6, 5. Sorry, this could be 9. But 7 here, 7, 6, 5, 4. Ah, this could be 7. 2 doesn't work. Yes, 2 doesn't work. Because 2 can never reach 4 or 6 here. Whereas 1 will reach. Wait, does 9, 8, 7, 6, 5, yeah, and then 7, 6, 5, 4. Okay, yes. 1, 2, 3, 4. So maybe I guess I could mark those in as well. If it was a 9, it would have to be 9, 8, 8, 7, 6. The other one would have to be 7, 6, 5, 4. 1 would have to be 1, 2, 3, 4. And if it's increasing here, it would need to be either 4... I mean, okay, it's very hard to tell. If it was 6, it would have to be decreasing, right? You can only reach 6 from 9, 8, 7, 6. Which would have to be 5, 4. And then if you started from 4, you could either increase 4, 5, 6, or you could decrease 4, 3, 2. So I guess those are your options. 6 is next to 1, 4 is next to 9, 2 is next to 7. Yep, that all matches up. 3, 8 here has to be next to... 3 is next to 2 or 4. 8 is next to 9 or 7. Well, this is 6 long, which does mean it must contain a 4 and a 6 in it as well. Because again, if you looked at the number line from 1 to 9, you selected any 6 digits, you must notice that the 4, 5 and 6 will always end up on that line. So this length must have 4, 5 and 6 on it, meaning 3 can only be next to 2, while 8 can only be next to 7 or 9. Which again doesn't help, but I guess that's something. We may have a missing digit from here, but I think we don't. That digit could be anything. Is this a different color? Wait, what? Oh my god, it is. I'm sorry if you guys noticed that, but I never did. Okay, can I remove 5 from that cell? I feel like I should be able to. Because I did it just now. I said that cell can't be a 5 for some reason. I don't remember how. I said that 5 is be one of those cells. Why can't 5 be there? What? Why can't 5 be there? Wait, yeah, was it just a mistake, or did I actually say something that was like useful? Because like if I said this is a 3, that would help immensely. If 5 was there, 4, 6. Yeah, I don't know why I said 5 wasn't here. It could have been a really good reason, but I honestly don't know. Yeah, no idea why. I'm gonna assume it was a mistake then. But that does really make it a lot worse, because now... okay. None of those digits can be 7 and 9, so 7 and 9 have to lie outside. But that digit could be 7 or 9, which makes it slightly better. None of those digits are 5, 7 or 9. But I guess 7 and 9 could be anywhere in those cells. Yeah, might be polarity time. I don't know. From the digits 1 to 9, the low polarity is 1, 2, 3, 4. The high polarity is 5, 6, 7, 8, 9. I guess this 5 length line has 3 of one of the polarities here. But it doesn't say anything about that, because that could also be the same polarity, you know. I guess maybe I could think about the polarities here. because those two polarities are the same, that polarity appear once here and once in those cells, which is to say what? Whatever polarity this is, you'd have 4 in those cells in total. So that and that have the same polarity. Oh, and because those two differ by polarity, then those two have the same polarity as well. All 3 of those. And in fact, those two differ by polarity as well. Because 3 goes with 6, 8 goes with 4, so they differ by polarity, meaning that all 4 of those are of the same polarity. Alright, screw it. I'm gonna draw lines. See this one? I don't know. Can I color them? Let's call these pseudo lines. We don't know which way they extend, but either option is possible as of now. Okay. Get rid of the color, which does get rid of this one. Can I draw lines over them? Oh, I guess I can. Cool. I can sort of cancel them out. I guess we don't really need to right now because we already have all of them kept in here. But now I guess I can start coloring polarity. Yay! So though we now know that all 4 of those are of the same polarity, and therefore all 4 of those will be of the same polarity. Now, 1 here goes with 2 and 3. Yeah, there you go. This can't be 1, because 1 will go with 1, 2, 3, 4, meaning those two be the same polarity. That doesn't work, so 1 can't be here. Therefore we know that orange is high. There you go. Which means that is now 8. Which means it has to be... Did I not misdraw a line here? There's a line here I didn't draw. Which means this must be next to 1 or 2. And in fact, because we know that this is all low polarity, that's 4. This must be 3. That is now 1 or 2. This is now 7 or 9. This is now 6. Which helps because this 4 means that can't be 7. Yeah, and therefore 9, 8, 7, 6, 9 doesn't work here. This must be 7, which goes down to 4. Which goes down to 3, which goes down to 2, which do work. That digit is now therefore a 9, that digit is a 1. Oh my god, we've broken in. Haha. 3 must be next to 9 because it comes next to 7. And we don't know about this. This is actually just a pair we can't figure out. Alright, 6. 6 in the middle means it either goes... Well, it goes in some direction. So let's just try and mark those directions. It either goes... 6, 5, 4... It either goes... 4, 5, 6, 7, 8... Or the same thing in the other direction. Which you could probably remove by... Yeah, this 5 means 5 can't be there. So 5 is just there. I guess we could have used that to give us all of that now. There you go. So coloring does help. Which is awesome. I love coloring. Oh wow, it marks the one over there. You didn't have to. But blue is now low, which is very fitting because blue is a cooler color. And orange is now high. You can mark that as high as well. So that's good. Okay, no, we can mark that as a 1 because it can't be 2. Because 1 can't be here, so that's 2. Those digits are now low digits. This one we still don't know. But we have triples here. 3, 4... Sorry, 3, 4, and 9. Those digits are 6, 7, and 8. Yeah, cool. And actually those are all just high, so I guess I'll color them in. This can be 7. Okay. Right, so where does 7 go in this row? It must be there. Because it can't be next to a black dot. The black dots are now 2, 4, and 3, 6, which do work, so congrats. We have gotten this sort of right. I think, for now. Nervous laughter. It could still be completely wrong. 4 means that... Well, I don't know what 4 means. Yeah, I don't know what 4 means. Okay. I guess we could continue coloring. 7 is one of those cells. 7 can be next to 1 or 2 only, actually. Right, so 7 can't be here. Because if this is 7, then what digit is that? It can't be 1 or 2, so therefore it doesn't have an option. So 7 must be here in this box, which means 1 and 2 must be next to it. So now we have the polarities of those digits, the polarity of those digits, which gives us almost a full set in this row. No idea. Well, that digit is 8 or 9. That digit could still be 6 if this was 1. This forms a pair here. Not sure if that's significant. 7 is one of those cells. 5, 6, 7. I mean, that digit is 8 and 9, I guess, but I still have nothing. 1, 2 pair means that the remaining low digits are 3 and 4, which can't be here. So where do 3 and 4 go? They have to go here. Which is a bit unfortunate, because 4 is with 2, while 3 is with 6, right? So both work here as well. But we know that digit must now be high, which gives us a lot of other colors. That digit is either 1 or 2, which works well. 6 could be anywhere in there, so I guess... yeah. That works. This is one of each, right? Right, so this contains one high and one low, meaning that digit... yeah, whichever low digit that is will complete the set, so that digit is high. Yes, and because they differ by 1, you cannot have high immediately go to low. They must transition through the 5 first, which isn't what happens here. Whoa! So we have... oh, no, I said they cannot change polarity through this consecutive thing here. In fact, yeah, because they're consecutive, they must be of the same polarity unless they contain a 5, which they don't. So here you go. This is now either a 1 or 2. 7 is in here, which must be with 6 or 8. I don't think we know which one yet. Because if 6 was here, then we know 6 is in here. But if 6 was in here, then we know 6 is in here. So no. I can mark those as 6, 8, 9, I guess. This one as well, this is also 6, 8, or 9. I did read some of the feedback for this puzzle, and I will say that yes, it is actually really fun to do, especially once you get past the packing problem. The packing problem itself was a really cool deduction, by the way. I wouldn't call it a deduction because I don't think I deduced it that well, but yes, I hope I deduced it to some extent. Okay. Now what? I guess 2 in this box is one of those cells, which looks up here in some way. 6 is in one of those 3 cells, which doesn't say anything. 7... yeah, we already knew 7 is one of those cells. I guess I'll mark them. Kind of squinting at my screen. I don't know if it's healthy or not. It's kind of small. I guess this is what I get for choosing the one with the full fleet beside it. I mean, trying to pack everything into one spot would be a lot harder if you only were given a list though, like in the 5x5. So I think this was somewhat helpful at the very least. So that's great. Right, hold on. Oh, I was gonna say something about this set over here. It's very hard to tell you what it is, but I will tell you that the three long ship, whichever one it is, has to be low, high, low. Because the 2 length will always have 1 low, 1 high. So the 3 length, because of these 2 high digits, the 2 length will have another high digit, so the 3 length one cannot have 2 high digits on it. So the ones on the outside must be low. Must be low, low, high. Can I prove? Yes, I can. Because this can't be your 3 length. If it was your 3 length, then those must be both low, which means that those are both high because they can't be 5, and you can't have two high digits that are ratio of 1 to 2. There you go. So that means that we finally figured out their 3 length is over here and must be 2 high digits. It also finally lets us mark the 5s properly. And actually this gives us 4 here because 5 must be next to 4, it has to be low. So it comes next to 6, 4 must be next to 9, which gives us a high digit, which I guess, yes. Cool. So this digit is now 1, 2, or 3. Okay, I guess any of them will work. Those digits, I don't know, but that can't be 9. Well, that digit contains 1. Yeah, that digit contains 1 high, which gives you all the highs here, so that is low. It gives you all the highs. Right, so there is 1 high, 1 low here. What does that say about maybe this column? Well, there's 1 high, 1 low here. There's 1 high, 1 low here. There's 1 high, 1 low here. So this would have 1 high, 1 low, which I guess I'll mark like that. And that gives you 3 highs and 3 lows. So this is 1 high. Okay, I guess we would have known that because this is 1 high, 1 low. Ah, of course. Let's see. There you go. Okay, where does 4 go in this box? 4 must go in here. 4 cannot go in there, sorry. So 4 must be on this line. It can't be on the edge, so 4 must be on the outside. And wherever 4 is next to, must be next to a 9. So that is a 9, which is actually a high digit, which means those are low digits. We can resolve this must be an 8. That is therefore a low digit, which isn't 4, which is therefore either 1, 2, or 3, but that means that is a high digit now, which has to be a 6, because of the 7 and 8 here. And this can't be 8. That can't be 8, which forms a 6-9 pair. Nice. This 6 means that's 2, means that's 1, which means that's 4. So this forms a 3-6 pair, which means that 6 has to be one of those 2 cells, which means that this must now be 7 and 8, which does help because now this can't be 8. That's 6. This is 9. That is 6, which must be next to 1. Okay, everything's unraveling. I love it. 1, 3 means those 2 digits are 2 and 4. That digit is a 2, which could be next to 7 or 8, so I guess that is something we don't know. That forms 3 and 8. This is a low digit, so that's 3. That's 8. Ah, 3 in the corner. Awesome. 1 goes there, 3 goes there. Those 2 digits are 2 and 8, which do differ by at least 5, so like that. 2 must be next to 4 because of the 1 here. 8 must be next to 4 as well, so that's just 4, which means that is just 9. I guess by this column you could have said that this can't be 9 anyway, so this can't be 4, that can't be 9, and actually this 4 means that's 3, this means that can't be 3, giving us a nice chocolate teapot. 6 can't go there. 1 means that's 2, that's 1. Cool. Okay. We still have these to explore. 2 resolves is 2-4 pair. But I think we could do a lot of Sudoku by this point, which is awesome. Yeah, the 2's here mean that 2 has to go here. So that digit is either a 1 or a 4, but it can't be a 4 because of the 4 here. So that's 1. This must be 8, 2, because it's resolved. This 1 means it's low. So that's low as well. Actually, that must just be 3. So those digits are now high. Can I say anything about this? I don't know. This 1 means that is 3. Those digit, well, that digit is 8 or 9 because it must be at least 5 away. The 9 here means that's 8. So now that can't be 8, giving us another chocolate teapot. How exciting. Those digits, well, those digits form a pair. That is 1 and 7. The 1 here means that's 7. That's 1. Those digits are 6 and 9. 6 here means that's 9. That's 6, which resolves this 6, 8, 7 triple. I'm sorry for saying that wrong. It's 6, 7, 8 triple. Anything here? I don't think so. Well, this 3, 9 means that's 3 or 9. This 4, 9 means that's 4, 9. This 3, 4 is part of the triple here, which are 3, 4, and 7. There is something here. I'm not seeing it. don't know what I'm not seeing, but the 1 in this column now can't be there, and we know not in any of those cells, so 1 goes there. I guess in this box we could have said 1 doesn't go there, so 1 goes there. That digit must therefore be a 4, which means 4 isn't in there. 4 can't be in here because we know 4 only has one possible neighbor, so 4 isn't there, meaning 4 must be there, which must make 9. The 3-7 pair would have also said that. The 3-7 pair means now that's a 4. This entire thing's resolved. Very nice. We're almost done. What else do we have? I don't know. That digit is, those digits are 6 and 8 though. Right, and 6 cannot be, 6 must be to 1, which isn't there, so this can't be 6, that's 8. That's 6, this must now be 3 because it can be 7. 8 means that's 7, that's 8. This can't be 6, so it's 3. And before I put the last digit in, I'm gonna redraw all the battleships so we can see better. And I'll redraw the battleships in pink because I like that. Crap, I lost all the battleships. So all those cells are battleships. Yeah, mark those. I can't choose to mark everything else, right? Yeah, there is no option to mark everything else as blue. Well, I can mark all the blues and then all the pink ones, and then, well, a fun trick that you can see is Control I actually inverses that. Oh, but the problem is it colors everything else as well. Crap. Not cool. Not cool. Okay. So there you go. Those are all not ship, which means that that is now a 6. Oh, there you go. You can't really see the mark, but ta-da! You solved the puzzle solutions correct, solved in about an hour. That was an awesome puzzle. And obviously I'll remove all of those. Nice! Wait, what? Remove... oh, sorry. There you go. I love that. Yeah, okay, so I will see you guys next time with the 4th installment. Hope you guys enjoyed this puzzle. I definitely did. Bye bye.